Next, I am going to talk about an appropriate data type. Your question may be, how can I choose an appropriate data type? And I'd recommend you to prioritize your importances to choose an appropriate data. For example, if you care about an area, then points and lines are not your choice, but polygon is. Also, vector data has high precision, but larger the file size is. There are tons of factors that affect the precision and file size. One of them is source scale, representing how detailed the data is. The black line in the right image is very detailed, but it has a lot of file size. Pixel size is another factor of raster data, and smaller size improves precision, but has more file size. Map scale is how smaller objects on a map than real ones. For example, a road is 1000 meter long in reality and 10 centimeter on the map. Then the scale is 1/10,000. Also, the road is 5 centimeter long on a map. Then the scale is 1/20,000. And if we want to calculate the real length, then we can divide the length on the map by the scale. So, for example, 5 centimeter or 1/20,000 is 5 divided by 1 divided by 20,000. So, it is basically 5 multiplied by 20,000, and the length is 100,000, which is equal to 1,000 meter. By the way, 1/20,000 is smaller than 1/10,000 because 1 divided by 20,000 is smaller. Let's calculate the length in a real example. USGS says that for maps on a publication scale larger than 1/20,000, no more than 10% of the points tested shall be in error by more than 130 inch measured by on the publication scale. For maps on publication scale of 1/20,000 or smaller, 1/50 inch. Let's fill out the blanks below. First, the error should be less than x meter on the ground in a 1/10,000 map. Here, 1/10,000 is larger scale than 1/20,000, so the threshold is 0.85 millimeter on a map. Hence, when we divide the 0.85 millimeter by 1/10,000, it is going to be 8.5 meter on the ground. Next, the error should be less than x meter on the ground in a 1/24,000 map, and the scale is smaller than 1/20,000, so the threshold is 1/50, which is equivalent to 0.5 millimeter on a map. Therefore, the error on a ground measurement is 12 meter. Naturally, because we cannot draw a line narrower than 0.5 millimeter, we estimate that error is always included in any maps. But usually there are larger errors than 0.5 millimeter in a map scale. Minimum mapping unit, or MMU, is a threshold of object size at which we can reliably map objects. If an object size is smaller than MMU, then it would not be mapped to remove errors and noises. For example, if we see a global map, our houses are not on a global map. Also, some maps convert polygons to points, to handle complexity and errors. For example, some cities are shown as points on a global map. We usually care about areas of cities, but the map uses points to handle layers efficiently and accurately. Let's review the concept. What data types can represent the below? First, roads in PNG. Second, national boundary of PNG. Third, bird sighting locations in PNG. Fourth, land cover in PNG. Road in PNG can be represented by line because we generally care about how long the roads are. National boundaries are usually represented by polygon because country has always have areas. Bird sighting location is usually represented by points because we don't usually care about areas that the bird occupies at a single time point. Land cover in PNG, it's usually represented by raster data. However, first base map in PNG is represented by vector. Both can illustrate areas, but polygons are more precise. Note, however, this may depend on scales and purposes. For example, I personally use national boundary layer in lines, not polygons, because I was interested in the length of perimeter. Also, cities are represented by points in global map, but polygons in a local scale. This is because global map is too large to represent all the city areas around the world. In the next presentation, I will introduce CRS and I will conclude the presentation.